welcome back. Good morning, students. Okay, today we'll discuss the combination of resistance. Okay, there are two types of combination of resistance: series and parallel. So first of all, discuss the series combination. Look, students, we are given three resistance wire. Okay, we are having three resistor wire having resistance R1, R2, and R3 are connected in series. As you can see, they are connected in series. Okay, with a cell having potential V and with a switch. Okay, and their individual potential are V1, V2, and V3 respectively. Okay, when the switch K is on, current I will flow from positive terminals to negative terminals. Okay, we are having a single path. Okay, that's why in series combination, current I will remain same. Okay, throughout all these resistance. That is important point. In series combination, current will be same. So now, students, in the previous lecture we discussed about Ohm's law. We know the mathematical form of Ohm's law. V equals to IR. We did last time. Okay, when we are having a conductor wire, okay, at constant temperature and at constant area of cross section, okay, V proportional I. Flowing current is directly proportional to the potential difference of the ends, and V equals to IR. R is constant. So I'm going to use this Ohm's law. I'm going to apply for first wire. V1 is the potential of first wire, current is I. So V1 equals to I R1. This is Ohm's law for first wire. Similarly, we can apply for second and third wire. For second wire, it should be V2 equals to IR2, and for third, V3 equals to IR3. Okay. Now, students, the sum of individual potential of all the resistance wire should equals to the potential of battery. Okay. So V equals to V1 plus V2 plus V3. That is total potential. Now, students, we know Ohm's law, V equals to IR. Applied here, V equals to IR. And now these values that we found already, V1 equals to IR1, V2 equals to IR2, and V3 equals to IR3. We'll put there instead V1, V2, and V3. It is quite simple. We'll take common I. So R1 plus R2 plus R3. I2 I cancel out, and finally we'll get R equals to R1 plus R2 plus R3. That is said to be equivalent resistance when resistors are connected in series. Okay, students? This parallel combination of resistor. Look, students, three resistor wire having resistance R1, R2, and R3 are connected in parallel combination with a switch, and with a cell having potential V. Now, students, when the switch is on, okay, current I will flow from positive terminals to negative terminals of cell, and at this point, that is junction, at this point, current will divide in three parts: I1, I2, and I3 respectively. I1 is coming from that side, I2 and I3 all will add, again it become I, and complete its circuit. So basically, the main thing is in series combination, current will be same, and parallel combination, current will be different. That is the main key for finding difference between series and parallel. It will help in numerical, which one in series and which one in parallel. Same current means series and different current means parallel. Okay, later we'll discuss in numerical. So now, students, I'm applying Ohm's law as V equals to IR for first wire, for second wire, and for third wire. So let's start for first wire. What should be the potential first wire? Actually, all three wires are held parallel to each other. In parallel combination, potential V remains constant. Okay. So V equals to I1 R1. V equals to I1 R1 for first wire. I applied Ohm's law. Find here, subjected the current. So I1 will be what? V by R1. Similarly, we can find current for second and third wire. It will be V by R2, I2 for second, and for third I3 equals to V by R3. As you know, students, current I divided in three parts: I1, I2, and I3. So sum of I1, I2, and I3 should equals to I. So what should be total current? I equals to I1 plus I2 plus I3. Now put the value. On account of Ohm's law, V equals to IR. When we subjected I, that's become V by R. So here I'm going to put V by R. Okay. Now put the value of I1, I2, I3. That is quite simple. V by R1, V by R2, and V by R3. We'll take common V. V2 we cancel out, and finally we get 1 upon R equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3. This is said to be equivalent resistance when resistors are connected in parallel combination. Okay, students? So now, students, question based on resistance, combination, series and parallel. Look, students, we are given a circuit in which we are given resistance 4 ohm, 4 ohm and 4 ohm. And these are 3 ohm, 3 ohm and 2 ohm. And he's asking find equivalent resistance between terminals A and B. Okay. In that type of question, we always solve the question from the closed side. See, this is a closed circuit and this is open. So this is our first circuit. We'll solve from that side. First, give them second, and give them as third. So now I'm going to solve first of all the first circuit. What happened in first circuit? Suppose when you flow the current, it divides at this point in two parts as I1 and I2. We know, students, I1 will flow in that also, I2. I1 will flow in this 4 ohm and that 2 ohm also. These two having same current. And you know, when the current is same, both resistors should be in series. So in first circuit, 2 ohm and that 4 ohm are in series. And we know very well, when two resistors are in series, what is equivalent resistance? R1 plus R2. So 2 plus 4, it will be 6 ohm. Now, students, 4 and 2, 6 ohm. And these two, including this and that, these two are held parallel with 3 ohm. Why? Because these two having same current I1, but this one having a different current. Same current was in series, okay, same current was in series, but these two become parallel with this 3 ohm because they are having a different current I2. So this 4 plus 2, 6, this 6 ohm will be parallel with 3 ohm. So write in same first circuit 6 ohm, it means 4 or 2, 6, this 6 will be parallel with 3 ohm. 6 ohm and 3 ohm are in parallel, and we know the combination in parallel combination, equivalent resistance parallel combination, 1 upon R equals to 1 upon R1 plus 1 upon R2. Okay, when we solve, we can write in this way also, R1 R2 divided by R1 plus R2. When we take LCM on reciprocal, we will get this form. So these two become 6 and that 3. 6 into 3 and 6 plus 3. Okay, 18 by 9, it means it will come as 2. So total resistance of first grid we got as 2. Okay, again I'm going to make this diagram. Look, students, this is the first grid, 4 ohm and 3 ohm. Suppose that is 4 ohm and that is 3 ohm. Terminal A and that's terminal B. Okay, students. Now that was the third terminal. This is second terminal. In second terminal, this is what? 4 ohm. I am going to write here 4 ohm. Okay. And look, students, we solved the first circuit, including these three. These two are in series, and after that, these two will be parallel with this. Okay. We solved the circuit. Now, what we got about this circuit? 2 ohm. So, including these three, we can write here as 2 ohm that we got. So, now we'll solve the second circuit. Same like, students. When you flow the current, again it divides in two parts, I1 and I2. Okay. So, again same condition will rise. These two will be in series. Okay, because why? 4 and 2 ohm are in series. Why? Because both having same current. So same will solve by this pattern. 4 plus 2, 6. Okay. 4 plus 2, 6. And this 6 will be parallel with this 3 ohm. So same like we'll get again 2 ohm. So similarly, as like first circuit, we can write in second circuit. Similarly, we'll get R as 2 ohm on solving this second circuit. So finally, what will write, students? Look, I'm going to solve here. for third circuit, look at students, this we are having 4 ohm, terminal A, terminal B, look, including these three, when we solve these three, we'll get 2 ohm. So including these, we'll write here 2 ohm. This is our third circuit. And finally, when we flow the current, same current will flow in these two. So both are in series. And we know what is the equivalent resistance in series combination? R1 plus R2. So finally we'll get 4 and 2. 4 plus 2, 6 ohm. So what will be equivalent resistance of this circuit? That will be 6 ohm. That is quite simple. These two are in series, and whatever the answer come, it will be parallel with this. Again, these two are in series. Whatever the answer come, it will be parallel. So we solved the first circuit, we got 6. Similarly, second circuit when we solved, again we got 6 ohm, and finally we got 6. So in this way, total resistance of this circuit will be 6 ohm. Understood, students?